Uh, what's like? I live by the beach. I live in California, and so I'm always at the beach. And then I kind of just look out and I see the boats go down, and it looks like they're going like they're going into the water. And the globe Earth theory kind of like makes sense to me when I see that because I don't think the boats are falling off like like a plate. It looks like they're dipping because the globe is a sphere. What's your guys' explanation for that?
Not a
Are
hill
you
of
saying there's a
water.
hill of what? Yeah. Oh, there we go. Here we go. I stepped out.
He's got a notion though that it's a plate, right, floating in space. Like you've already got your mind made up of what flat Earth is, right, bro?
Well, yeah, well, it's in the name
you need to
flat
cut
Earth.
that out
There are
and start
certain
from
like
scratch.
there's like a visual when someone says flat Earth. Like I've seen like renditions of what like a flat Earth looks like on Google Images.
Yeah,
Some of them are more
Seen what it
silly
looks
than
like,
others,
bro.
but like there's one where it's like a plate and it's like on the back of a turtle.
Yeah,
I don't know if that's what you guys believe in.
Yeah, that's Terry Pratchett. That's a completely different story. So I think
Oh, okay.
CB, yeah, CB said it. I'm not sure if you heard it.
Not a hill of water. Not a hill of water.
So what do you mean
It's
it's not a hill of water?
So what you think is blocking your view of the boat?
Yeah.
What that's not is
Not a hill of water.
It's not a hill of water. I didn't say it was a hill. But
wait, so what is the boat going over?
Basically what I'm asking is there's a boat, it starts driving away from me in the ocean, and then eventually like it starts sinking until like I can only see like the mast or like the top chimney part, and then even that sinks into it's like, well, why does it do that?
So what is it going over again?
Because what happens is it doesn't get so small that I can't see it anymore. It literally dips below the horizon. So
And that is,
can I just get an explanation for what causes that phenomenon?
yeah, so one more time. What's the boat going over again?
What's it going over? Nothing.
So what is it disappearing behind again?
The horizon.
And that is, in this case, it happens to be curved water, right?
Curved water. I don't know what you mean by curved water.
So it's a boat, so it's on water, right?
Yeah.
And it's like the horizon. You're saying it's going down below the horizon, right?
Yeah.
And then that would be water that's curving, right?
Yeah, I guess it's like, well, so what I'm asking is, if we're taking the flat Earth perspective, right? What's the explanation for that? I can explain it with a curved Earth perspective. I just want to know what the flat Earth perspective is for that answer.
What we talk
CB,
about.
CB, can I interject here, CB? I just want to simply ask him, hey, buddy, do you think it's possible to observe the same phenomenon that you're describing? Is it possible to observe that on a flat surface?
I think literally anything is possible, but I would like an explanation for how this is happening.
No, hold on. I just asked you a closed-ended question. There's a yes or a no. So
wait. So I gave you a direct answer. I said, yeah, I think anything is possible.
Oh, okay. All right. So then you admit then that it's possible for this phenomenon to happen on a flat Earth, since it's possible for it to happen on.
Yeah, I mean it's possible that like the boat just like is like teleporting or something. I don't know. I'd love to just hear what the explanation is.
I don't know what you're on about now with the boat teleporting thing. You were just talking about something getting further away from you and it disappearing from the bottom up, correct?
Yeah.
Okay.
Yeah.
And now I'm clarifying now. It is possible for this to happen on a flat surface, right?
Sure, I guess. It's logically possible.
Okay, so the ocean is level, which is flat, and this is happening on that flat surface. There you go.
Which I guess it would mean that the boat is sinking into the water. But I feel like if that was true of every boat that drove really far away from the California beaches, we would be losing like hundreds of thousands of ships. Because I live near Long Beach, which is one of the busiest ports in the world. So that would be like hundreds of, if not thousands of boats lost every day. I feel like that would be a lot of money lost, and I feel like people would stop doing it if they were sinking into the water.
Oh, bro, chill. Boats are designed not to sink, so that's not what's happening.
Oh,
You're
okay,
saying
okay.
over a hill of water, which is what you said. It's not happening, which I agree with.
Yeah.
But that's your point, is that there's a hump of water, or the water's curving, and the boat has now gone behind this hump, or below this
Sure.
hump. Yeah,
Well,
okay.
the Earth is curved. Yeah,
We got
yeah,
him to
sure.
say it. We got him to say it, at least.
Fair enough.
So I would just say that water doesn't behave this way, very simply. Water does not, at its surface, it's not convex nor concave in any body of water. I would say all bodies of
But
water
like
are the
with
same,
the
and they're
yeah,
neither convex nor concave, which means it's
yeah,
flat. And then you also don't have the ability to see forever, so you're not going to see this boat just across the entirety of the sea. It's going to
yeah.
disappear from view eventually, bro, for multiples of reasons. It's not going
Sure.
into the water, and it's not going over a hill of water either.
My counter to that would
Yeah,
be
he's asking a specific
my counter
question.
to that is that and you guys may say this is like fake or like a production of NASA, but like isn't Neptune like a planet that is just like a big thing of water? And
No.
it does I'm not, if I'm not mistaken, it looks pretty circular to me. So
It can be, but it's not like the Earth anyway. So we're talking about the horizon, though, bro. So
no, wait. What do you mean it's not like the Earth? Like if the entirety of Neptune's surface is an ocean,
that's not
that
confirmed.
means that the water is curving, right?
Not a hill of water, no. It's not a hill of water in the sky.
Not a
So
hill of water.
wait. So wait. Is Neptune? Wait, are you saying Neptune is not real? What are you saying?
It's
No,
just
dude, where'd you get that? Where'd you get that from?
Where did
Who
I get
says
what from?
Neptune is a giant ball of water? Do you have a citation?
Every, I guess.
Every? Can you cite one?
Like I don't know, common like my book on planets when I was like 8 years old said that, I guess.
Oh,
I
yeah.
don't know.
Oh, interesting. Okay, so can
Yeah,
you like
my elementary school like teacher?
Okay, cool. So if every source that you've heard mentioning
You're telling me
this,
Miss Williams lied to me? Is that what you're telling me?
that's not what I'm saying. What I'm asking you is to get one
I
of
love
your
Miss
citations
Williams.
out. That's cool.
Oh, I don't have any
Sounds like
citations.
Okay,
Miss
so you got
Williams, no, Miss Williams was just repeating what she was told. She was not consciously lying to you. Don't worry, bro.
Okay, fine. That good. Thank you for saying that. I was worried for a second. But so wait. So we don't believe Neptune is real, or we believe that it's not actually an ocean covering the surface of it.
Let me help you out
What
here.
are we saying about Neptune? That
There's no such thing as the vacuum of space. So the vacuum of space is a fictional setting. It's wonderful for books, video games, movies, etc. But the vacuum of space, much like Narnia or Hogwarts, is not a real place. All right, it's not a real thing.
Yeah.
And
Why are we
so
jumping all over the place here, man? Let's stick on the water.
We acknowledge that
You guys, let CB hold on. Ryan, let CB. He's doing good. Just one on one. CB's really good at this topic.
Because I don't want to talk about the vacuum of space. I want to talk about Neptune. Because specifically, Neptune seems like a good way that I can understand how water works on Earth. Because if Earth is a globe and Neptune is a globe, and the water on Neptune can curve, presumably that means the water on Earth could also curve. At least it could be possible that it does, right?
I think you're making stuff up a little bit, because I just looked up if Neptune was a water planet, and it said no, it's not. So it's an ice giant. So I don't know it's not a water ball, bro. I don't know who told you that. Miss Crystal or whatever her name was. I don't think she said that either. But bro, let's come back down to the Earth here. You said the horizon was curving water. So that's kind of the
Is
crux
Neptune not a giant ocean? It is a gas giant. I'm retarded.
Facts.
Wow. Okay. Damn. This was like the quickest fucking SmackDown I've ever had.
Guys, hold on, guys. In your paradigm, you guys aren't quite describing it properly. Like, the gas giants have oceans. The way they describe them is that they're an ocean down at a certain level.
How the fuck do you know, man?
And there's gas above that. But again, it's just a big fairy tale, alright? Like I said, the vacuum of space is a fairy tale. And
Respect the speaker, sir.
Wait, no, but I'm seeing how that, Neptune isn't even primarily composed of water. It's primarily composed of like methane and oxygen.
but it's in a liquid form is the way they describe it. It's not water, but it's a liquid still.
Interesting.
They're not even saying that.
See, like I had this idea that it's like literally like a fucking.
It's a fairy.
Subnautica, like it's like a giant like ocean planet.
No. Go ahead, CB.
Man, whoever is running this soundboard is doing an awesome job. Props to you, dude.
Soul into this. So just come back. Let's come back down to earth.
Yeah.
Come on back down.
Sure. But like you know what I think of, and you guys may disagree with this. Have you ever seen like those astronauts in space or on the space station, and they squeeze out like a thing of like a droplet of water, and it makes like a circle. It makes a sphere.
We're coming farther back down to earth, all the way down, back down to the horizon, bro.
So we are coming back down to earth, but I guess what I'm describing is that if what the globe-tards say about Earth is true, then the water on Earth would behave like the water behaves in zero gravity, which is
the example that you just gave is within a contained environment. The globe is not a contained environment. You remember that the water in the liquid state and forming a bubble, whatever, that's contained, and
contained
that would be analogous to the globe.
Contained in what?
No, I wouldn't base your reality off of something you've seen on a screen. The guy's floating around. Now you think you should float around. You see water in a ball. You think water should behave like a ball. I would not compare.
I'll tell you, I've seen droplets of water before. I have observed that it does water, because of its surface tension, does like to make itself into a sphere. So I imagine I don't think it's like a big stretch to imagine that like a droplet of water suspended without gravity would take the form of a sphere that when like it hits my windshield while I'm driving when it's raining, it also makes a sphere.
Well, water and small examples do weird things. If you put water in, say, like a beaker, and then you're going to end up with a meniscus. We're talking about bodies of water. So bodies of water, you can put your body in, maybe like a bathtub, swimming pool, or larger. I would say that the water in all those cases behaves the same. At the surface, it's neither convex nor concave. So then in the ocean, with the boat disappearing, it's not going over a hill of water, as we discussed earlier.
Okay, so what is it doing then?
Well, it's just moving away from you. We agree that it's not sinking into the water. This is both designed not to do that.
Well, what I'm saying is, I'm coming to you with like, complete ignorance. I'm saying like I don't know what's happening. What I said was I've seen with my own eyes that it looks like it's sinking under the horizon. So I'm just asking, for someone who believes in flat Earth, how do you explain that phenomenon? What is happening? I'm like a child. Daddy, the boat looks like it's sinking. What's happening? And you go, oh, well, son, this is what's happening. Go ahead, do that for me.
It's no different than the sun. It's just moving away from you. It's not actually going down below anything. And again, the horizon's not a hill of water, so it's not going down behind a hill or anything like that.
What do you mean it's moving away from me, though?
Well, you said earlier the boat was driving, which I thought was funny. You said the boat was driving away. So
presumably, if it was just moving in a straight line away from me, it would just get smaller and smaller and smaller. It wouldn't go downwards.
Reality should behave differently. We don't have to say that, because reality does behave the way it does right now. That's not going to change. So you shouldn't say things like, well, it should do this. Like, no, it just does what it does on the flat Earth.
No, but wait. So you're comfortable basically saying you don't know why it does that?
We just told you it's just moving away from you, dude.
No, but if I look up at something going straight, wait, but like let's say I shoot like a bottle rocket that's just really powerful and it keeps going straight up, right?
You got a lot of hypotheticals.
Like it will just get smaller and smaller until I can't see it anymore, right?
The horizon remains level.
Yes.
No, but it's not going up at the horizon. I'm looking straight up, 90 degrees, right? There's no horizon for it to fall behind. There's nothing that will like obscure my vision of it. It's a perfectly clear day, right? What will happen is it'll just get smaller and smaller until I can't see it anymore. Why isn't that happening with the boat, though?
It's not very analogous to the water. and the horizon. We're discussing what the horizon is would be the key factor here.
Yeah.
In your worldview, the horizon's like a physical hump of Earth curve. That's what we
You
joke around.
already admitted that the horizon isn't physical. So
Oh, then what is the horizon to you guys?
It's just in the name. It's in the name and the definition. Apparent junction. So it's a visual thing. It's a physical phenomenon.
So
it's
wait,
not a position.
Are you making a statement that like something about like something at a very far distance causes like a optical illusion or something?
It's the apparent location where the Earth meets the sky. That's the definition.
So wait, if there wasn't this optical illusion and I had a really powerful telescope, would I be able to see Japan from California?
Oh my god.
Well, there's things
is
in
the horizon an optical phenomenon or is it a physical location?
Japan is a physical location. It's not an optical phenomenon.
Is it or is it not?
I'd like to think Japan isn't an optical illusion. I've never been there, but I'm pretty sure it's real.
Bro, I'm going to help you out. Listen, he asked a sincere question, friends. Hold on. He asked a sincere question. He didn't need to be guffawed at. There actually is a sincere answer to his sincere question, right?
I'm still waiting for it.
Okay, well, I'm helping. So how about you be quiet? So anybody know the answer? Yeah, I'm giving them the opportunity to give the answer, dude. How about you let me do the modding and you do the quieting when I ask you to be quiet? How about that?
Okay, go ahead.
Thanks.
There is an experiment that actually proved gravity, right? Apart from every other experiment related to Earth. For example, do you know who Cambridge is?
No. Cambridge or Cavendish?
Cavendish. Yeah, University. That one. Sorry, I was confused. But
you don't know who it is. That's fine.
Cavendish is someone who made the experiment that proved the gravity.
Okay. 1. Cavendish didn't provide a hypothesis. 2. This mass attracting mass violates special relativity. It was superseded in 1915 by Einstein. So no, there is no scientific experiment, Cavendish, that proves mass attracting mass which violates special relativity according to Einstein.
Just out of curiosity, how does it violate special relativity?
Instantaneous action at a distance. You'll notice within Einstein's equations, there's a coordinate called time, which means things take time, not instantaneous action at a distance. For example, within mass attracting mass, if the sun was moved off of its position instantaneously, that force of gravity would act instantaneously on all other bodies, including the Earth. This violates special relativity. Do you require citation?
No. I was just
okay.
Just out of curiosity. No. Now, did the guy, what was his name? Facondito. Do you want to go on?
Facondito, yeah, I know he's able to unmute himself. Facondito, did you have a question? I don't know. He's not unmuting.
Okay. Maybe he had to go use the bathroom or something. But anyway, back to what I was saying. I think you guys would all agree that with your observation, you can tell that there are certain things that have act and certain. I'm not even going to go into like potency, but there are certain things that have acts. Okay, in life. I don't think I have to define what acts are unless you guys want me to define them. But there are actions that we see in objects. Okay, objects have propensities to do certain things. This only requires observation, right, to see. Okay, I don't have to be a scientist to know, okay, that there is a massive light in the sky during daytime. And that the sky that I'm looking up into the air is blue. Right?
That means all things go down. Is that what you're trying to get to? We can observe all things go down.
Yes.
Okay. Right. Gas expansion into a vacuum. Gas behavior violates that claim. Gases move freely and randomly in all directions.
Gravity satisfies that criteria.
Okay. You do realize I'm speaking about the second law of thermodynamics, right?
Mm-hmm.
Cool. Gas that has temperature, kinetic energy, is going to continuously move on a straight path until it has a physical collision with another gas molecule, another physical structure, or the walls of its container. So within the second law of thermodynamics, which simply states gas expansion into a vacuous space, we don't have the observation of gravity acting upon the gas.
Okay, so if
you're going to keep through me, then I'll just put you on mute because it's annoying, and then I'll unmute you when I finish talking.
I don't know why you're trying to be such an asshole, man. I'm agreeing with what you're saying, so I'm following.
Okay.
I'll let you know that I'm following.
So you understand that your claim of gravity isn't anywhere within the second law of thermodynamics?
No. It satisfies the law of thermodynamics because essentially because there is a force acting upon
Okay, so there's a temperature increase on the Earth, is there?
Again?
There's a temperature increase on the Earth, is there, because of the gravity pulling the gas down, causing thermodynamic radiation, heat increase?
I mean,
It's
you
a
have to
violation
prove
of the
that there is
second
the
law of
case.
thermodynamics to claim that gravity stops entropy taking place.
You're saying
entropy
that
takes place 100% of the time. You can't get away from this fact. You're saying no, but gravity stops that.
It take place 100% of the time. I'm not denying
Yes,
that.
it does.
But if there is a force acting upon entropy,
if there
keeping it
is
in a
a
certain
force,
place,
sorry,
yes,
I do apologise.
which we observe.
Excuse
in our
me.
world.
I took the force away from you just like 5 minutes ago. Gravity is no longer described as a force since 1915. Special relativity, right? General relativity, no longer a force. It's not the mass of the Earth attracting the mass of the gas.
What matters is that gravity still exists.
Excuse me. It is not the mass of the Earth attracting the mass of the gas back to it.
Yes, it is.
Not that. No, it isn't.
Yes, it is.
Okay. Do you know who Einstein is?
Of course I do.
Cool. So general and special relativity. Gravity is not a force of attraction between masses. The mass of the Earth is not attracting the mass of the gases to it, according to Einstein.
Okay, if you want to get into your nuanced definition, yes, that is the case. But the fact of the matter is that the more mass you have, the more it's going to attract certain objects. Okay, that's the case.
Incorrect, according to Einstein. Now, define mass.
In general relativity. In general relativity.
Oh, goodness me. Define mass for me. Tell me it's doing something.
Things that have matter.
Things that have matter.
Yes.
Okay.
Yes.
Next question. How do things that have matter
how is that not a good
Excuse
definition?
me. No, I'm going with it. I'm taking it.
Okay.
How do things that have matter attract instantaneously over space other things that have matter? Tell me how.
I never said it attracted things instantaneously over space. You put those words in my mouth. I never said that.
So not the mass of the Earth attracting the mass of the gas to it then?
It does attract the mass to it, okay?
Okay, so we have to go back to what I'm saying because you're jumping around all over the place. You're not listening. It is not mass attracting mass.
I've been following you all this time. Go on.
Cool. So what gravity should you be speaking to?
Well, gravity, the mass that is pulling you towards the Earth.
Oh, the old and busted. Newton, physics, superseded in 1915
It doesn't matter.
Einstein.
It doesn't matter. What matters is what we view with our eyes.
Quick question.
I'm talking about what we see in terms of perspective.
Oh, we don't see. What we do see is expansion of gases to fill space.
Yes, we do.
Dude. Does gas fill space?
Say again?
Does gas fill space?
Does gas do what in space?
Fill space. Does gas expand into vacuums?
Gas would expand into vacuums if there's not a force blocking it in the way.
So you disagree with the second law of thermodynamics?
No, I don't.
Which quite simply states gas expansion into a vacuum, the mixing of ideal gases and fluids.
If you've taken normal physics, then you understand.
That's what someone else did. I'm too far above your pay grade. Shitting hell.
Am I muted?
No, I am. I'm muting myself, so you can talk to someone else. I'm not wasting my time with you.
All right.
Okay, does anybody else have a question about the flat Earth or ways you think you've seen
I want to talk. I'm too scared. Okay.
Don't be
Once and four.
Don't talk, then.
Why are you being such an asshole to him?
No, you can ask your question, and then when somebody chooses to answer it, we might just mute you. We might mute you when the people are answering like we did before. But then we'll unmute you at the end because you do seem to have a problem with the listening.
I'll mute myself. It's okay. I'll mute myself. Just one question. Is space fake for you guys? Someone said in the chat, he said space is CGI.
It's fake for you, yeah. Yeah, it's fake for you too.
It's not fake, it's real.
No,
you guys
it's not.
Don't see
It's
SpaceX missions?
It's just on TV and movies and YouTube.
Nobody's saying that the lights in the sky are fake. We're telling you that the story about outer space that you were fed as a child is fake. As fake as Santa Claus.
I cannot believe that space is CGI. Space is
You'll be
fake.
fine. You'll be fine. Everything's okay. You'll be okay.
Yeah, different voices. Like, that's not going to last long. Yeah, see? Toho Cumin, you're up next.
Yeah, he came in last time and then he did that screaming goat screech.
No, I didn't. We're
Not
talking
you.
about
Talking about Screaming Goat.
not you. Yeah, you're next, so Toho Cumin.
I'm next? Why?
Yeah, globe proof. Do you have any proof of this mini globe?
Why would I have any proof?
Well, I'm just asking a simple question. That's the topic of this room is Earth, so, that's why we ask. But if you don't have any proof, join the club. We agree. We look for proof We found none. No one's provided any. So welcome to Flat Earth. Mike, do you want to chime in? Do you have any globe proof? Mike L5.
Well, probably not.
Can I ask why you guys think the Earth isn't a globe?
Well, because, okay, so you and everybody else in here experiences Earth as flat and stationary, horizontal. And we know we have gas pressure here. Gas pressure, the cause of gas pressure is a container. In all instances, gas requires a container. In order to obtain pressure of gases, you must have a container. There's no such thing as gas pressure without a container. So as far as our experience, flat, stationary, level, sea level, we know water is level on top. So that was everybody's experience. So that's the baseline. So if you think Earth is anything but your actual experience and everyone else's, then you would have the positive claim. So you think Earth is a globe then. So do you have proof of the globe?
All right, so you said that the gas pressure has to be in a container. What about like gas in a balloon? Does that not have pressure?
Yeah, is a balloon a container?
Well, no, but it surely has pressure, right?
Well, yeah, it's a container.
You can't be this fucking stupid, can you?
You have gas pressure inside of a balloon that's contained. What if you poke a hole in the balloon? You no longer have gas pressure.
I'm just referring back to your claim. I don't know what gas pressure has to do with a flat Earth.
Oh, well, it has to do with Earth because we have gas pressure, 14.7 psi at sea level.
All right.
So in order to have a constant pressure, you need constant volume. In order to have constant volume, you have to have a physical barrier that contains the gases in order to cause gas pressure. That's a prerequisite. It's the antecedent for pressure is a container. So that's what it has to do with. Otherwise, you wouldn't be able to breathe. If we lived in an open system, the gas would all fuck off into space, and none of us would be breathing here.
Wait, so are you saying there's a uniform pressure?
Atmosphere.
No, we live in a dynamic system with a heat source that moves above us, the sun. As the sun moves across the surface, it is causing dynamic variations in pressure and temperature. So we live in a very highly influx, system that we live is very highly dynamic. So it's not uniform because that would be something where there's no change in temperature, no change in pressure. Well, we know we have changes in both pressure and temperature.
Couldn't pressure also just change depending on how high you are?
Yeah, you're talking about a gas pressure gradient. The gas pressure gradient always occurs within a gas pressure system that is already contained. So in other words, like I said before, if you have an open system, you don't have gas pressure gradients. Gas pressure is required in order for you to have a gas pressure gradient. You see how you have gas pressure itself, delta, gas pressure gradient, delta X. You can't have one without the other.
Hard to argue with that.
Pardon?
I said hard to argue with that.
Yeah, so we could stick with the basics, that what we all observe out in nature is a horizontal plane that we live in. That's how everybody builds on horizontal plane using level. The level that you use in, let's say, building, it is parallel to sea level. Now tell me, can you have level on a curved surface? And how would you go about that? How would you obtain level on a curved surface?
That is a good question.
Yep. Well, they tell us that there's a tangent to the top of the ball. And let's say there's a tangent to the top of the ball that you create a horizontal line balanced on the top of a ball. Okay, so let's say you're at that location. which would be the apex of the curved surface. You're at the very top of the ball at all times. So that, let's say you're at point A, and you've managed to create a level by balancing a straight edge on a curved surface. So let's say you can obtain a level. Well, what happens if you're a mile or two at location B, you're at 2 miles away? Then what happened to your level?
Years.
It's not at the same, it's not level anymore. It's an angular difference to location A. So that means if you were at location B pointed up directly straight up, and the person at location A pointed straight up, they would be angularly different to each other. So no longer level. So you could never navigate like that. We navigate using things called a sextant. And what we do with the sextant is we take a sighting on celestial bodies, the sun, moon, stars, or planets, and we get an elevation angle from the horizontal plane, the plane of the ocean, horizontal sea level, using the horizon as level. We zero the sextant at the horizon, and we measure the elevation angle like a protractor, and we get elevation angles. And then we move to another location. Let's say we're traveling along, and we see another star. We get another sun. We get another shot, elevation angle to another source or celestial body. And then let's say we do that 3 times. What we do in navigation is we would use those celestial sightings at those points where the star or the planet is at zenith. It would mean that each one of those bodies has a GP or a ground position. In other words, they're directly over a certain spot on the Earth, geographic location, at that time of day to the second, and you draw what's called circles of equal altitude around the GP of those celestial bodies. So let's say you have 3 of them. You draw circles of equal altitude around those 3 bodies where they are lined up to be the GP or ground position, where the stars are directly above at zenith. And where those circles cross each other, you're inside of that crossing area. That's your location. This can be done very accurately. And so that's how we navigate, using a horizontal plane. So remember I asked you how you could get level on a curved surface, which clearly showed that you can't do that because every location would be a different angle and would not be level any longer. So if you're traveling along that x-axis, along the ocean, if it was actually a curved surface, you could never get an elevation angle because you can't get an elevation angle from a curved surface. We're basically using right triangles. And you know what a triangle is, right?
Yes.
Yeah. So what are the identifying things of a right triangle? You know much about geometry? Anything at all? Like how many degrees?
90.
In a right triangle, 3 sides of a triangle, you have
Oh, my bad.
180 degrees, yeah. But you're right about the 90, which would be your right angle. So the adjacent, which is the line, the straight line that's adjacent to the right triangle, in order to navigate successfully, accurately, using flat charts that we navigate with, using rectangle coordinates, you have to have a straight line. You can't have a curved adjacent. That would not be a triangle that you could use in navigation because it would have more than 180 degrees. So we've navigated like this for centuries. Many, many centuries. Possibly even in prehistory. So we observe the water as flat. We observe the Earth as flat, level, stationary. We practically use it as flat and stationary. In any flight models, they're using the Earth. They're assuming a flat, stationary Earth, including NASA, Boeing, Northrop Grumman, Teledyne Ryan, any of the other manufacturers of aircraft. They use what's called a linear flight model. All these linear flight models for aircraft assume flat and stationary Earth. So we all use it as, practically speaking, we all use it as flat and stationary. So I would ask you, who uses the Earth as a globe and what technology uses it while traveling across the Earth? on, above, or below the surface, what technology is using the globe Earth? Silence, I'll take that as you don't know yet. Maybe you haven't looked into it in very much detail. I suggest you go ahead and look for that information. While you're out there looking for what technology that's traveling on the surface of Earth is using the curvature or the globe Earth metrics, because they gave us the size of the Earth. That was a big mistake. They told us it's 3,959-mile radius. So that means there's a certain amount, a specific amount of drop over distance on the surface that has to be there. And you can go look at any Earth curve calculator or a curve chart. It will show you exactly how much drop over a certain distance. So while you're looking for what technology is using the globe, I suggest you look for any time in history when anybody has directly measured the drop over distance or the curvature on Earth's surface. So that would be a good start for homework. So you can do that on your own time. But meanwhile, if you have any other questions, go ahead and feel free to ask. It's open to the panel. I can mute up. Someone else can answer if you have more questions, but feel free to ask. I suggest you do your own research and check into this yourself. It's a fascinating topic. And the reason we're all here is because we asked ourselves or were asked by somebody else to go out and check this information that I've asked you to go check and found no answers. Thanks.
Alrighty, thank you.
Gas pressure without a container inside a big giant vacuum chamber, which is outer space. Yeah, so that's not possible. Have a look in the side chat quickly before you respond. Have a look at what secret Asian man just posted.
It's not matter. This is called pseudoscience. Okay. Okay, so it is my first time hearing about a container, and I do not disagree with it. It's a really nice, a really thoughtful theory, and I want to believe it. It's really great. I just have one question, which is not fitting in my mind right now. So, if we are in a container where gaseous pressure is so much that we are able to form an equilibrium and we are not moving, the pressure needs to be really, really high, right? It leads to two things. Pressure is high, then force on us living beings should be really high. And second thing, if pressure is high, if the density is as much equal to as of Earth, the stones and everything, then density is really like anti-proportional to volume, right? Inversely proportional to volume. So, so particles of air or gas should be so close so that only we can achieve a density as much as that of Earth and stones. So if particles are that close, wouldn't it be visible, or like it's really close, like we should feel it. It's not in the regular gaseous format where particles are really randomly moving from each other and the mean space between them is really large.
Well, the air as a whole, right? That's just a medium filled with gas. So it doesn't really have anything to do with the relative density argument, right? On a larger scale, you're more dense than the gas, right? You're in the medium of gas, of air, and you're more dense than the medium, right? If you were less dense, like a helium balloon, right, you would float up through the medium, right? But because most things are more dense than the air, you're going to sink, right? Like if you pick up a rock, it's going to sink through the air because it's more dense than the air. Does that make sense?
Yeah, I agree with the theory. Like, it's not about gravitational force or mass pulling mass. It's about density. I got that theory. It's really nice. So that's why I believe, like, if you're standing on Earth, then our density was higher than that of our surrounding, but it's just Earth supporting us and we are standing there.
Yeah.
My question is...
Yeah, that's correct.
Yes. Yeah. So my question is, if density is the playing role, so we are standing on Earth and Earth is not moving, then our surrounding density should be greater than or equal to that of the Earth, right?
Sorry, just a moment. Yeah, so can you restate that question again for me?
Yes. So as you already said, like if you're standing on Earth and you're not floating away, then that means Earth density is greater than that of our surrounding. So I agree with that theory, and it's actually a really new and innovative concept. So a follow-up question.
It's not a new theory, though. This is it's like Archimedes' principle. Oh, for you. Yeah, no, I got you. All right, continue.
Yeah. It was for me, like maybe it's a really established theory, just for me it was new. So now if our Earth, so now I'm assuming our Earth is stable, right? It's not moving. That means it's an equilibrium. And if it's an equilibrium, then the density of surroundings should be equal or at least greater than that of the Earth. And right?
Well, are you assuming that the Earth is an object in a space vacuum?
No, not in space vacuum. No, it's in a container. Yeah.
Well, yeah. We also don't know the extent of the Earth. We don't know. Like, we're not making a claim that we know the shape of the Earth. Right. So let's just say we could think of as the Earth as the foundation of this Earth system that we live in. Right. You could probably refer to it as like a realm or something like that. Right. But the Earth would be the foundation. What's underneath the Earth? What is the Earth? Nobody knows that, right? All we're talking about is that when we go and measure large distances over the surface of bodies of water, there isn't any curvature, right? The curvature that would be required for the Earth to be a globe, right? So we're not claiming to know the extent of how this entire system works, but we can explain why things in nature go up or down based on the relative density, right? Because we can test it. We can test it over and over again and get the same results. Yeah, so I'm not sure exactly what your question is.
Yeah, so let me summarize this. So initially I was kind of trying to figure out for myself if Earth has a curvature or not. For that thing, I had this important question like, do gravity exist or do objects pull each other together? And I got to know from this VC and that no, gravity doesn't exist and we actually have density, and it was a really innovative concept for me. So I'm just building on top of the concept, and there was another theory which was we are in a container. I kind of want to agree with that theory. Okay, we are in a container. Vacuum doesn't make sense either for me either. So if you're in a container and if you're not moving, and we believe in the concept of density, so I just wanted to say that the density of our surroundings should be equal, right, to that of Earth's, so that the Earth is not moving. It's an equilibrium in the container, right?
What do you mean by the Earth is in a container?
You said that, right? If we are in a contained
No, I said that we have gas pressure, right? And the necessary antecedent to gas pressure is a container. So it's kind of, let me give you an analogy, right? So do you know what I mean by antecedent?
No.
Okay, so it's something that's necessary for something to exist. For example, if you have a beef steak, right, you know that it came from a cow. Okay, so you don't need to be able to prove that it came from a cow because you have beef steak, right? Or if you have a human being, you know that it took a mother and a father to create that human being. Okay, so like two parents are the necessary antecedent to have a child, right? A cow is the necessary antecedent to have a beef steak. A container is the necessary antecedent to have gas pressure. So we know that we have the gas pressure, right? So we know there must be a container of some kind. Yeah.
Okay, so a container is a prerequisite for gas pressure, right? Okay, I agree.
Yeah, prerequisite. Yep.
So my question is, if we go by the concept of density and we are not moving, then if like you said, like if helium balloon has less density, so it'll just float away. We humans have more density, so we are standing there in an equilibrium. Another force was our platform we are standing on, right? So my question is, if our Earth is an equilibrium, so that means Earth's density, which is made up of stones and heavy metals, so Earth's density is less than that of its surroundings. Not less, at least equal to that of its surrounding.
What's the Earth's surroundings?
Pressurized gas, right? That's my question.
Well, no, that's just the medium that's within the container, right? Think about, do you know what a terrarium is?
What?
A terrarium or a vivarium?
Type it out, I'll just search it.
Yep. I'll show you an example.
Oh, like an aquarium or something. Okay.
Well, not really. It's like a self-contained micro ecosystem, right? So here's an example in the side chat, right? So this is essentially a mini version of what we experience here on Earth, right? We have a container, and then we have the soil, and then we have the plant life and organisms that live on top of the surface, right? And then we have a whole bunch of cycles in the system, right? There'll be nitrogen cycles and all that kind of thing. So gases are going to constantly be produced and used and recycled, right? So it's like an ecosystem. Now, the medium, right, that's inside this container is primarily air. Okay, so all of the other matter inside the container is more dense than the air. So that's kind of like if you look up a larger version of that, here, I'll put a video in the side chat because this is a really amazing one. Okay, 1 second. All right, so here's a giant vivarium in the side chat. Right, so this is essentially like a mini version of what we're dealing with here. Right, it's a self-contained ecosystem, and it requires obviously a container to be able to have the gas pressure that supports the life inside of the ecosystem. Right, and it's a dynamic system, not a static system. So it has all of these different processes taking place within the container.
Gotcha. So, okay, so let me tell you what my question was based on. So I was saying if Earth is floating in its container, then that means its surroundings density should be...
Earth is not floating in a container. Yeah, Earth's not floating in a container. Like, see, have a look at the vivarium. Have a look at the vivarium, right? Well, hold on a second. The ground isn't floating in the container, is it?
Yeah, that's why I wanted to agree. Like, this was my presumption. I actually wanted to admit that. So, yeah, so I'm telling you, initially I thought like Earth is floating in its container. So that's why if it's floating, then the surrounding density that should be equal to that of Earth. That means surrounding should be filled with rocks as well, and we should all die, because how can we live in a surrounding which is as dense as that of Earth, right? But now you made it clear, like we kind of have support from the base, right? This is what, it's not floating, right? It's having a support from the base. So now this just, I don't want you to go into infinite loop. Like, for example, if our container is, now our Earth is stable, right? But because we are taking this support from the container, it's not floating. So now our container is taking support from somewhere else, right? There should be a bigger world, right?
Well, who knows? Yeah, mystery, isn't it? Like, the deepest hole that we can dig down into the Earth is 7.6 miles, right? And yeah, no one's ever just kept going south to see what the extent of this place is. So yeah, it's a big mystery, absolutely. But let me give you an idea to think about here. What would happen if we took this vivarium that I showed you in the side chat and we removed the container and put it inside a vacuum chamber, a big vacuum chamber? Everything would die very quickly, right? Yeah, all the water would boil. Yeah, all the water would boil, right? Because the high pressure wouldn't stay above the surface. It would just instantly equalize with the vacuum around it, right? All the water would boil instantly and turn to vapor, and everything would equalize, and the gas would fill the available space. Then the plants would die, and it would be very chaotic and a bad day for the vivarium. So that's what they're kind of claiming that we have, right? They're saying that we're an ecosystem like this inside a big giant vacuum chamber, more powerful than any vacuum chamber that we can create here on Earth. Deep space vacuum, 10 to the negative 17 torr.
Okay. So, just returning back to the small discussion. So now in our vivarium, Earth is supported by our container, right? Now it will be an infinite loop. Like, this container should be supported by something else. That container should be supported by something else. We don't have to go in that loop. But my question is, if vivarium is there, if the walls of the vivarium are intact, that means outside pressure and inside pressure is equal, right?
Well, not necessarily. I mean, the pressure outside of the container could be higher or lower, right? It's not until you release the container, like a valve or something like that, that's when the pressure is going to try to equalize, right? The high pressure is going to fill the available space, right? High pressure goes to low pressure.
How the container is going to stand still if the pressure from the inside is lesser than of outside? Of course, given the container might have its own bit of mechanical strength, but in general, if the pressure is really, really high, as we're talking about, because our Earth is there, then it should be equal, right?
Well, why would it be equal?
You can maintain the equilibrium. Our walls are not shattering, right? The walls.
Well, not really. I mean, to shatter, we would have no idea, like what's outside of the container of the Earth, right? Like, we have no idea. There's no way to check anything like that, right? So we're not saying the container's inside a space vacuum.
It's not.
No. Well, we don't know. We don't know. We don't know exactly how the sky works. We can only validate what we can validate.
Oh, my question is just simple. Like outside pressure, our container walls are also in equilibrium, right? If they are not shattering, they are in equilibrium, right?
Well, the container walls are, we have no, like, what specific example are you talking about here? Are you talking about the Earth or the vivarium?
The vivarium. For our Earth, the analogy is
Well,
for
the
our Earth,
vivarium, it's glass. It's a pretty dense material.
No. Okay, not vivarium. For our Earth. So I'm just saying, if
So we
something
don't
is not in
know. We don't know
equilibrium,
what the container is. We don't know what the container is for our Earth. All we know is that we have the prerequisite for the container.
Mm-hmm.
Yeah, that's all we know.
So I agree. I want to believe we have a container. I want to believe that. But my question is, if something is at rest, if it's not moving, then the net force and pressure on it is zero, right?
Well, whatever pressure is inside of the container will be pressing against the walls of the container, right? But because this is a dynamic system that we're talking about, so you're going to have a pressure gradient inside the container because you have constant gas production at lower levels.
A small delta doesn't matter. I'm talking about if there is a difference between pressure, the walls should move, right?
No, I don't think the walls should move. No, the walls are solid.
It will not be in equilibrium. It will not be in equilibrium, right? The external
No, I think you're
internal
misunderstanding. I think you're misunderstanding equilibrium in this situation. I don't see why the walls would be moving. Right? It's a solid structure when we're talking about the vivarium, right? It's glass. It's a glass enclosure.
Talk about vivarium, we have air inside and we have the same air outside. That's why we are in equilibrium.
Yeah, but the entire vivarium as a whole is more dense than the surrounding air on the outside. So it's just sitting on the floor of the person's house.
Mm-hmm.
Yeah. Fill it up with fill it up with enough light gas, and it's I guess it's still not going to float away because of the weight of the glass and the dirt and everything, but yeah, it's already in equilibrium. Everything's in equilibrium. I'm not sure what the problem is.
Yeah, that's what I'm saying. If it's in equilibrium and our internal density is mix up of what do we call it? So internal is air, right? The air we breathe in.
That's just the medium, not the density, right? That's just the density of the medium that's filling the container.
Mm-hmm.
Yeah, so you could fill the container up, right? So just say you filled the container up with water, and now you have a fish tank. Right now, you have completely the objects inside the fish tank or whatever. They're going to act completely differently. All the wood's going to float up to the surface, right? The everything's just going to act differently depending on the medium. Now, the air is a very light medium. It doesn't have a lot of density to it, so most things are just going to sink through it. Something doesn't have to be very dense to sink to the bottom of a medium of air. It just has to be more dense than the air.
Just let me state the question in a very simple way from where I'm coming from, how this question started. So we talk about there is no mutual attraction between masses. It's more about density. And I'm saying our Earth has a density. It's made up of rocks, heavy metals. It has really high density, right? And if we are not free falling, and if nothing is happening to us, that means we are in a medium which has at least equal density to that of our Earth. That means if not here, immediately here, but we are living in a surrounding of rocks. Everything filled with rocks. That's why we are in equilibrium, right?
Well, so it's different when you're talking about solids, right? You could have like when you're talking about solids, it's different to if you're talking about fluids.
So
you could have it right, but it's still equilibrium, right? So you could have like a piece of wood isn't a medium. Like we're talking about fluids when we're talking about mediums in this sense, when we're talking about relative density. So you could have a piece of something really heavy, right? Like a piece of steel, right? It's not going to sink through to the bottom of a piece of wood, right? It's going to sit on top of it.
No, so for example, a human is a solid block of mass, right? It's not a fluid. Yeah. But if that law is applicable, so why don't humans float away?
Because humans are more dense than air.
Yeah, right. So we are applying this density law on humans, who are not fluids.
Everything.
Right?
Yeah, everything. Mm-hmm. Yeah, humans are more dense than air.
Yeah. So I just want to apply this law on Earth. If Earth is not floating away, then the Earth's density is lesser than that of a surrounding, right?
No one knows what the surrounding is. We don't know. We don't know. Yeah, we don't know. Nobody knows that.
But if a surrounding has as much density as that of Earth, we shouldn't even be breathing right now because Earth's density is really too high and all the molecules, atoms are closely packed. We wouldn't have space to even open our mouth if we live in
that doesn't make any sense.
as
That doesn't make
densities.
any sense at all. It literally makes no sense whatsoever what you're saying right now, unfortunately.
I'm just trying to equalize the densities.
So if you have a container and you put air in the just look at the terrarium. Why can't the animals in the terrarium breathe?
Right. So
they can, can't they? Well, hold on. How come your theory doesn't apply to the terrarium?
No, it applies. It applies. So my question is,
we have an ecosystem. We have an ecosystem in the terrarium, and it's air. It's breathable air, and you can put little animals in there, right? And they're going to live.
Right.
So the Earth is just essentially seems to be a larger version of that.
Right. So if you are protected by some container, then that container is not moving. That's a godsend to us, right? The container is literally a holy place for us. But the container is not moving, then the container must be in an equilibrium state, right?
Why would the container move? It's solid.
But it needs to. So the container should have its own surroundings, right? It's present somewhere in the surrounding. Yeah, it's a structure, and outside of the structure is its own surroundings, right?
Yeah, so look, we can confirm that with the terrarium because we can test what the container's made out of, right? We can test what the terrarium is placed in, right? At someone's room, in their house. We can't test any of that with the Earth. All we know is that we have gas pressure. And to have gas pressure, you need a container, right? That's all we know, right? And then we can test the Earth and we can confirm that it's not a globe. That's all we know about the Earth in relation to that.
Right. So if we have a terrarium, sorry for this spelling.
I didn't say that. I didn't say that. I said we have gas pressure. I said we have gas pressure. I didn't say we have a terrarium. I said it's similar to the way a terrarium. Yeah, I'd say, I was just showing you a terrarium, right? To show you that you can. Yeah, I was just showing you that to show you that to have that ecosystem, right? You need the container. You can't put that inside a vacuum chamber or everything will die.
So we are in a container, right?
Well, we have gas pressure, so yeah, it's most likely a container.
Right.
It just gets ridiculous at that point. Just gets ridiculous.
Okay, that's fine. I have to leave, but I would really like to continue this discussion tomorrow.
All right, so just hold on a second, right? Because I feel like you're LARPing. Okay, so I just want to post this, right? Just to show you. Here we go. NASA, right? The density of the universe exactly equals the critical density. Then the geometry of the universe is flat, like a sheet of paper, right? And that's from NASA.gov.
Mm-hmm.
Do you know what LARPing means?
No.
It's when you're pretending to be something that you're not.
That's fine.
Yeah, so there's the source. Anyway, yeah, so they claim it's a flat universe, right? So
I don't know
what's holding up the flat universe? Yeah, what's holding up the flat universe? Yeah.
Yeah, so there are theories of
how's gravity hold up the flat universe? How's that work?
Right, so they're talking about multiple universes. So there is a probability.
That's not what they say. That's not what they're talking about here. It doesn't mention multiple universes. They tell, like, when I speak to them about this, right? When I speak to people that follow this, right? They say that it's expanding into nothing. And then I ask them what nothing is, and they just say it's nothing. It's just nothing. They don't say multiple universe. It's expanding. What, the other universe also expanding into this universe? They can't all be expanding into each other, can they?
No,
it doesn't make any sense.
Yeah, I agree with you.
Yeah.
But have you heard this theory of multiple universes? Have you?
Yeah, it's all crazy nonsense when it comes to these crazy claims from outer space. It's mathematical like garb, right? And as Michio Kaku says, nobody in his field uses the scientific method. It's just based on guesswork.
Mm-hmm.
Yeah, wild ideas.
So when we talk about guesswork, we have it both ways, right?
No, we can empirically test the Earth, right? So when it comes to the claims that we're making, we can empirically test the Earth, right? By taking measurements of the surface of the Earth. That has to be curving. It has to be curving if the Earth's a globe, right? You can't have 10 miles of flat water on a globe. That's impossible. Right?
That is the exact initial discussion we were having. So we have completed one loop right now, and we can go on again on the same loop. I'll have this discussion with you. It's really great discussion, but I have to leave right now. So there's something I can carry from this conversation is what we have a base and what's outside of it. This is something I'll think about. What you can probably think about is the equilibrium, right? Maybe you can study a bit about equilibrium in the containers, like how outside pressure and inside pressure plus mechanical force is supposed to be equal, so that the container.
You're assuming there's outside pressure to the Earth system. That's just an assumption. Right? How do you know that there's outside pressure? How do you know there's any outside pressure?
That's for me to figure out, right? I said, like, for example, there is nothing outside of Earth in the container. That's what I'll figure out, right? And you probably.
How are you going to figure that out?
There's something I will ponder over. There's something I'll ponder over. There's something I'll worry about. We'll think about it. If I can reach to conclusion. Probably at the same time, maybe you can go for the equilibrium only if you want to. No pressure. No pressure. Okay.
Yeah, that's what you would have if you're in a vacuum chamber.
Yeah, that's what I love because
the globe in a vacuum chamber. Yeah.
Right. Okay.
Yeah, you couldn't have a gas pressure system in a vacuum, could you?
Yeah,
a container.
I agree,
yeah, wouldn't work with it.
Yeah, I got it. Right. Thanks a lot. Thanks a lot, teacher. Thanks a lot, everyone. Bye-bye.
Farewell. Yeah, definitely a LARPer.
Yep, I don't know. Looks like she has the perception of the Flat Earth Society model floating this in space.
She was just a bullshit artist LARPer pretending to be a flat earther and thinking she had some kind of gotcha argument with the equilibrium thing that she was talking about, which was just absolutely ridiculous.
According to you guys, how do you think like the Earth is flat? From what perspective you think?
Well, from everyone's perspective, from your perspective, from my perspective, you go outside, the Earth doesn't seem to be spinning, does it?
Doesn't it look to be spinning according to you?
Yes. Well, according to everyone, no one detects the ground spinning, do they?
Okay, so you talk about the Earth is flat. So tell me about something. Your theories. You must have some theories how the Earth is flat. I need to know about that.
Yeah, it's observed, measured, and practically used as flat. Do you know what those words mean?
No, I'm curious. Like an equation you have solved that solves the measurement and equivalent to the something like equation you have made. Yes.
Yeah,
The
so
Earth is
the Earth's
perfect.
surface just measures. No, we're not saying it's smooth. It's topographical, right? So it's got hills and valleys, but bodies of water at rest are flat and horizontal. Sea level is a horizontal reference datum used to measure all elevations on Earth. So, yeah, we know by the nature of water that the Earth is majority flat with bits of land sticking out of it.
Do you see it?
Pretty simple. Yeah, every day, go outside.
So if I see the moon, I see it's not like.
No, see, this is where you guys are easily confused. So when we say Earth, that refers to the ground beneath your feet, the surface that you live on. The moon is a light in the sky. Do you understand?
So it's not makes sense.
So the Earth, so the ground beneath your feet, not the moon. You understand that?
Yeah. So you mean every the Earth? It's not look like the moon. That's you.
The Earth is not the moon. The moon is different.
Even different for anything.
Yes, it's not the ground beneath your feet. So the moon would be a celestial body, and the ground would be terra firma, terrestrial.
Sugar, the ground is not in the sky.
Yeah, the ground is not a light in the sky. Pretty simple.
Oh shit.
So when we're talking about the Earth being flat, that refers to the surface that we live on, not the light in the sky we call the moon. Hopefully that's clear. Any other questions? So we've got the topic of the event is, have you ever seen the Earth's curvature? Sugar, it's okay. I'm just going to check what else is going on.
Hello.
Chipson, what brings you by the chat?
I mean, I'm just here to listen, but I cannot speak, I guess.
Well, cool. So welcome to the chat. So the topic of the day is, have you ever seen the Earth's curvature? Do you think you've ever seen curvature of the Earth?
Yeah, I think I see. I saw.
Okay, where do you think you saw it?
So I'm a photographer, okay?
Okay.
So when you have a big lens, you can see the Earth's bending, like you can
like a fisheye lens, like a fisheye lens, wide angle lens.
No, not like the fisheye lens, like the 200 or the 400, like longer lenses, because you can see the far beyond the eyesight sometimes, and when you see it like that, you can your mind can't understand, but you try to understand, and it's like okay.
So what altitude would you say that you're seeing? So what altitude, what height would you say you are when you're seeing the curve?
I mean, like my drone, I use drones sometimes, and when you go up to like 2K ish something, you can see it a little bit, I guess.
Yeah. Well, that's a problem.
Why?
Because according to the globe math, you wouldn't be able to see curvature of the horizon even at 250 miles up in the air.
I'm not a scientist.
I know, but I'm just telling you what they're saying.
Okay.
They're saying if you're seeing any curvature below that height, it would have to be a distortion, a lens distortion, or some kind of window that you're looking through. Yeah, because according to the math, you wouldn't see it. So their story is not that they're an altitude that you could get to or send
Who
something
says
to.
that? Who says that? Okay.
Well, the likes of Neil deGrasse. You heard of Neil deGrasse Tyson?
Yeah.
So guys like him.
Okay. I mean,
guys like him or he?
Like him, yeah, because when you say someone,
look in the chat. Someone can post a video of him saying that. So he's talking. There's a video of him. Have you ever heard of the Red Bull jump? You remember the Red Bull jump a few years ago? So he came out. He was doing a talk, some presentation to people, and he was explaining to people that the video of that got released that shows this curved horizon, this curved Earth that he's jumping above, is a fisheye lens, because at the altitude that he's at, you wouldn't see any curvature, and he was at
it was a fisheye lens, but when you use
120,000 feet. So that's higher than your drone can go, or that you can go. And he's saying you wouldn't see any curvature there. So he's contradicting what you're saying.
But do you know the ships?
That stuff is flat.
Yeah, that's Neil deGrasse Tyson saying that's flat.
Do you know the ships? Like when you look at them, they might be half of them. You cannot see the half of them because.
Okay, now is that an optical phenomenon or a physical phenomenon?
I really don't know.
Okay, there you go. That's a good point for you to think on, because you're right. They tell us in school, they say, hey, you live on a big spinning ball because you can see boats appear to disappear bottom up. And they say that's because it's going over a curved Earth, right?
Cyclone, I posted the image related to this in the side chat.
All right, so guys, if you're not in the side chat, open up the tech channel associated with this VC because people will be posting images and articles and things to go along with what we're discussing, yeah? So boats over the horizon, that's a good one to discuss.
This guy's not disappearing behind the curvature of the Earth.
That's just a hill.
Yeah, this is optical. See?
So you said you don't know if it's optical or physical that's causing that.
Yeah.
So how do you know a way you could test that?
I don't know.
So if you go on Google and you go onto Google and you type in distance to horizon calculator, can you do that?
Yeah.
And when you do that, a bunch of different calculators will come up. Just click on any one of them, and you'll be able to put in your observer height. Just put in your observer height, 5 foot, 6 foot, whatever it is. Just imagine you're standing on the beach, and then tell us how far away it says the horizon should be.
Wait, my internet is not well, like yeah. Okay. Say 1 minute. So it says if you surface level is 1 meter, it's 3.5 kilometers. It says.
Okay, so you're standing on the beach, you're looking out. You understand that is saying if a boat was to leave you from the beach, from the shore, at 3.5 kilometers, it would have to start disappearing bottom up because that's the curve of the ball.
Yeah.
Right. So let's imagine you go and test that. You go down to the beach and you start looking, but you don't see it start to disappear bottom up at 3.5 kilometers. You can still see it at 10 kilometers, 15 kilometers, 20 kilometers, and it still hasn't started disappearing bottom up. It hasn't even reached the horizon yet. The horizon's off in the distance. What does that mean? What would that mean?
I mean, if you look non-cloudy, foggy day, you can see the other countries. You say so.
No.
If I look from my
stick with the example, dude. Stick with the example. So you're standing on the beach. It's saying you should see the horizon and the boat disappear bottom up at 3.5 kilometers. Yeah.
But if you look, I'm living in Turkey. Okay. I'm living in Turkey. Okay. If I look from the Black Sea, can I see the Russia or not?
Well, we can get into all this. We can get into all this. I need to understand that you understand what we're talking about here. So let's say you go down and you don't see it disappearing at 3.5 kilometers and the horizon isn't at 3.5 kilometers. It's actually, you can see it over 15, 20, 30 kilometers. What does that mean? What does that mean?
It means the Earth is flat.
Well, it would at least mean that let the guy, was that the same guy? Who's answering here? Is that the guy I was speaking to or is that a different guy?
Different guy.
Right. The guy from Turkey. I'm speaking to the guy from Turkey. What's your name?
Eren.
Say it again? Eren.
Yes, Eren.
Okay, welcome, brother.
In his profile up there, it says Chipson, right? That's who we're talking to, the cat. Chipson.
Oh, Chipson, right. Okay.
My name.
Yeah. Okay, so you would. So if you see that the horizon is not where the calculator says, and it's way in excess of that further, what does that mean?
Yeah, it might mean Earth is flat, but I need to go to space and look for it. You know.
No. You don't need to go to space. You don't need to go to space. You can just go to the beach.
You don't need to go to space. You don't need to go to space. But even if I say something that you don't believe, you will not believe me. You know. You'll believe what you
this is why I've given you an example of something that you can test yourself.
Okay.
That's why I showed you the calculator and told you to go to the beach. And you live in Turkey, you've got plenty of nice beaches.
Yeah.
You can go and check that out, yeah? And like you said, if it's not matching the calculator, then you have to come to a decision as to why that is. And yeah, the real option is that it's because there is no curvature. So there's no horizon there.
Can I ask you one question? Let's say world is flat, okay? Let's say world is flat. And why will they say Earth is not flat?
It's a religion.
Yeah, why is the government lying to us?
Yeah. Why?
Why do governments usually lie?
I mean, because of the money, because of the power.
Oh, there you go. There's two good reasons.
Well,
there's two good reasons.
I mean, you can say 9/11 happened because of the Bush. I mean,
check
a lot of things.
There's a lot of we could speculate a lot of reasons as to why they would do this. But yeah, basically power, control over your mind.
Can you answer one question though? One question of mine. Could you answer, please?
Well, maybe you can ask it. I don't claim to have all the answers to every question in the universe.
So I've climbed a mountain and I've seen this curvature of the Earth that you talk about.
No, really?
Yes.
You sure about that?
Yes.
Could you show me a picture?
Yes, I could. I can't send it in the chat because I'm not the level, but I could send you the image itself. Just give me 1 second.
Yes, send it to one of my beautiful assistants.
Who is your beautiful assistant?
I posted here in the side chat this image. I can't. There's literally a religion associated with this.
So you're telling me?
Hold on, AJ. Hold on. No, this guy is wanting to share an image.
Yeah, he can send it to me if he wants.
There you go. There's one of my beautiful assistants.
Let me look.
So just while he's sending that, I've posted a 360-degree pan from the top of Mount Everest, showing a completely flat horizon.
What?
It's 3,000 kilometers below the Earth. I mean, like, what is your point?
Yeah, so
that's not how you
there's
see
no
the
curve from Everest. There's no curve from Everest, so that kind of debunks your claim.
Yeah, okay, so that means literally nothing for me.
No, it does, because you said I went to the top of a mountain and saw curvature.
No, I didn't.
Yeah, you did say that. Well, whichever one of you said it. Whichever one of the guys that said it. Okay.
Yeah,
DJ's showing us an observation from the highest mountain, and there's no curvature. So
here's the thing, right? Everest is actually not that tall compared to how long the Earth is in diameter. Now,
but that doesn't matter. The guy said he saw a curve from a mountain. This is the highest one, and there's no curve, so it's debunked. That's not even the globe story, dude. We're not going to waste time arguing a point that the globe side on the mainstream isn't even making. You are confused if you think this is what they're saying. If you think they're saying, hey, you can't see curve unless you go up a mountain, they're not saying that. They're saying that you can't see it from any altitude you can go to. You can't see it from a plane. You can't see it from putting up a balloon. They're telling you there's no place you can go to see it. Only they can, because they're going to space. So come on, dudes. We're not going to waste our time with that.
But what you're saying about the light? Light, the sun, the big sun.
So
what about it?
Like when I'm in the Ecuador, it's changes positions, right? I mean, it's not the same.
It moves? You're saying it moves?
No, not moves. Like, you know,
the sun doesn't move?
No, it moves, but you know the sun clock.
Yeah, the sun's like a clock. Yeah, a sundial.
Yeah, sundial.
Because the sun's moving. The sun's moving.
That's why. But I've been in the Ecuador, okay, and I've been in somewhere different, like not the Ecuador. So when you look on that day in the 12 o'clock, it was like had a bit of angle, okay, and in my country, in Ecuador, it was like completely flat. You can't see any sun. What you say about that? Like,
well, the sun's visibility depends on where it is over the Earth in relation to you. The sun moves over the Earth in a repeated cycle, and when it's in your vicinity, it's daytime. Okay. When it moves away from you, it's nighttime. And it's daytime in another part of the Earth, and it's moved over.
So you're saying, how can it be? Like, how
can it be? That's what you observe, dude. You observe this in the sky every day.
Okay. So in my country,
the sun can reach Pluto 6 billion miles away, kilometers
really?
away.
How do you know how far away it is?
Well, what do you know? How do I know how far away? I certainly know it's farther away than.
You said what did you say? How many miles? Six what?
6 billion.
6 billion. Wow, that's a long way. How did you measure that?
It's Pluto.
So how did you measure that? Oh, you didn't. Oh, so you just heard a story.
Would you agree that Pluto is farther from Earth than Chile is from Australia?
Well, what's that got to do with anything?
That's got to do with everything, because essentially Pluto gets sunlight, but Australia can't get sunlight when the sun is over Chile.
No, Pluto is a luminary. It's a light in the sky.
Oh, so Pluto is just a light bulb then?
I didn't say light bulb. It's observably a light in the sky. It's a luminary.
It's like one
just like the sun, moon, and stars.
Well, okay, so
just one for a sec. Why are you in the server, English Hub?
Who? Me?
You sound to speak English very well. Yeah. Are you a teacher here? You a tutor?
No, I'm not. No.
Okay. Why are you here then?
I don't know, just to talk to people, really. That's it.
Okay. All right. Fair enough.
Yeah. So, okay. So you said that.
Hold on. AG, you were saying you were posting something in the chat?
Yeah, I posted something related to what you were saying. Has to do with the sun.
Okay.
He made a claim related to how far away it is. I was just posting a very interesting observation from Africa.
Okay, do you want to explain what's being observed in the image, or
which one?
The sun. Basically, I would say that the sun doesn't set. It fades off into the distance after it travels a certain amount of space between you and it. Sorry about the background noise.
Okay, so he's showing the sun moving off into the distance, appearing to decrease in
area size. What you were saying, man. I'm not trying to take him back or anything.
No. That's good. No, that's helpful. Thank you. Because this might be an observation. This isn't necessarily an observation that everyone has of the sun, depending on where they live and what the general air conditions are like. But if you're somewhere particularly dry, you could see the sun move like this, and that doesn't seem to be setting around the curve of a ball.
Okay. Could I ask you how the system in the night works in this model of the flat?
Not really, because I'm not making really any claims about the luminaries. We can't go up there and test them, pull them apart, figure out their mechanisms. We can only observe what they appear to do above this flat, motionless plane we're on.
Okay, so do you know the canal between the Russia and the Alaska, right?
Your mic's a little bit muffled. I can't really hear what you're saying.
Do you know the canal between the Russia and Alaska?
The what between Russia and what?
The channel.
Oh, channel.
Channel. Yes.
The
Bering Strait. Is that what you're talking about? The Bering Strait.
Yeah. Very.
Okay.
So if Earth will be flat, we wouldn't put a direct straight line in the Alaska and the Russia.
Yeah. You could shoot if you had like a powerful laser. You mean you could shoot a laser from one side to the other? Yeah. Well, it depends on exactly what distance you're talking about, but yeah, in general, you're right. A laser is a good tool to use to see whether or not there's curvature or whether it's flat, and this is what a lot of people have done, and they've only shown that it's flat using lasers.
How?
Can someone post in the side chat some videos of the laser tests? It's easier for you can just watch these videos and you can see people are standing on, say, one side of a lake and shooting a laser to the other and taking the globe math and comparing how far they should be able to shoot the laser. And they find that they can shoot it much further because there's no obstruction due to the curve, because there's no curve. But someone can post in the side chat. We've got videos of this, so you can have a look.
Yeah, I'll find some.
And we would recommend that you go out. You don't necessarily have to do a laser test, but you can do long-distance observations. Just test how far across the surface you can see.
I'll do it. I'll do it. Okay. You know what I'm gonna do? I'll go. Okay. You know what? Let's make an experiment. Where do you live? Where do you live right now?
Well, your experiment shouldn't matter where I live.
No,
I'm in Scotland.
Like Scotland, right? So is it dark outside or is it sunny?
It's nighttime.
Nighttime, right? So I want you to look at the moon, okay? Do you see the moon? Like, if you look at the moon, can you see the moon?
Not at the moment, but let's imagine.
Let's imagine the moon. Yeah. So you know how moon looks, right? Like it's the half of the
I'm familiar
moon.
with the moon.
Yeah, it's half of the moon you can see and half of the dark side, right? So why is the half of the moon is dark and half of it you can see the sun?
Well, do you remember I said earlier that I wasn't making claims about the luminaries because we can't test them? We can't pull them apart. We can't go to them.
Yeah.
We can't test their mechanisms. So my argument was about the lasers on the surface measuring flat, remember? Not the moon. That's not my argument.
Yeah.
So the moon doesn't tell you that you live on a spinning ball. It just tells you that you have a moon above you.
Okay, but if you have a moon that is a flat, you should have a I'm
not making a claim about what the moon is.
You should, if the world is flat, then you should have the base. World needs to be based off the universe because you can't just put a moon on top and.
That's funny you say that because some people do say, some people do describe the Earth as the floor of the universe, with everything else above you.
Oh, wow, that's incredible! Can you explain to me lunar eclipses?
What do you mean explain them?
So the Earth is flat, and in this scenario, the sun and the moon both are on the top, but still somehow the sun casts a shadow on the sun casts Earth's shadow on the moon, and still somehow.
Well, see, the problem. See, the mistake you're making there is to assume that it's Earth's shadow on the moon. You don't actually have any evidence that that's the case.
What else a shadow would it be, dare I ask?
Well, it could be its own light doing its own thing, and its own light has phases of it. It doesn't necessarily require the shadow of another object.
Could you repeat the last thing you said? Could you just? I didn't quite catch that.
Well, the moon on a flat Earth doesn't have to be a spinning ball of rock having a shadow cast onto it. It could be
I heard you say
a million other things.
Light doing its thing.
Yeah, it's a luminary. It is its own light. It's not reflecting or having shadows cast onto it.
Light. It's not a light bulb. We can say that it reflects the sun's light. It's not a rotating
What is the moon? What is the moon? What is the moon?
It's a satellite.
What does that mean? What does that mean?
It means that it's a small planetary object. That it is a small
planetary object.
Heavenly object.
Heavenly object. So what's it made of? How far away is it? How did it get there? Do you know any of this?
Well, not by the figures, no. But I know that moon is made out of, well, I could say matter, but that wouldn't be specific enough. But
no, it wouldn't.
Here's the thing.
Because you have to make a specific claim. about it being a ball
claim,
a certain distance away, but spinning, and that's having Earth's shadow cast upon it. That's your claim, but you don't have any evidence for that claim.
And the counter evidence to my claim is that light is not doing anything.
I don't need to make counter. I don't even need to make a counter, because if you've got a baseless claim, it can just be dismissed.
Okay, so I will ask you, how does the moon glow? Because we know this, that the moon does.
You claiming the moon is a globe? Oh wait,
No,
what did you say? Glow or globe?
How does the moon glow?
Well, how would you verify that?
How do you mean? How would I verify that?
How would you ascertain an answer to your own question? If you could imagine a way to do it, how would you do it?
That it reflects off the sun's light.
Okay, well that's just a claim again. How would you verify that's the cause, or that's what's happening?
How would I verify that the moon, it reflects off the sun's light?
Yeah, and then it's a spinning ball of rock. You couldn't verify it, could you?
Well, the one thing is that the moon is tidally locked, so we see only one face of the moon.
You don't know that either. Well, you do know that you only see a circular face, one circular face of the moon.
Yes, we see one circular face of the moon.
Yeah, so you don't know that it's a spinning ball that has another side to it. You've never seen that.
No, a spinning ball is on the topic. Now I have to prove that it's reflecting off the sun's light. So
if you'd like to try, please feel free.
Yeah, I could like to try to give the example that usually what happens in space, as you see in nebulae and everything, unless something is really hot, it doesn't begin to glow. And since the moon isn't made out of gas, it's not made out of plasma, it's made out of matter and rock.
No, you don't know what it's made out of. This is you just making claims again. Remember, this is the thing you're trying to prove. You've just restated it as a claim without any proof.
It has visible craters on it. You know what craters?
Has maybe to you what look like craters. Okay, so how would you go and verify that those are craters on a 3D rock ball having sunlight cast onto them?
No, I'm not saying, I'm not even arguing whether it's a ball or not.
You are. Your whole argument requires it to be a ball. It has to be the globe story. You're arguing for the globe story of the moon.
I'm arguing for the Earth being the globe right now. I'm not.
No, you're not. You're talking about the moon. Okay, but I'm glad you're saying you're going to go back to the Earth, because that's actually what we're talking about. The moon is completely non sequitur, and you have no idea about it. So how do you prove that the Earth is a ball? Let's do that.
Can I prove that the Earth is a ball? Okay.
Yeah.
The moon. We know that.
No, not the moon. The Earth. The Earth. The ground beneath your feet. You want to prove that that's a ball?
Yes. Could you maybe listen?
No, because if you're going to say just look at the moon, assume it's a ball, and then assume that the ground you stand on is a ball,
again,
that's not evidence.
You're
okay, well, if you're not going to do that, go ahead.
Okay, so essentially, what the point I would have made is that if you are, let's say, in Canada and you look at this moon, then you see this planar face. Let's call it a planar face, all right? And it's the same face for everyone. But now, when you go and you see this planar face from Buenos Aires, it is that same image from Ontario, Canada, but it is flipped along the x-axis.
I thought you were going to be proving that the Earth is a ball.
Yes,
okay.
I am.
When are you going to do that?
I just did, because if you're looking...
No, you're talking about the moon. You understand that the moon is not the Earth, yeah?
And do you understand that if you do actually go and step outside, you would be able to, observe...
Yeah, observe a flat, motionless Earth, yes. We're aware of that. But you're claiming that observably flat, motionless Earth is actually a spinning ball. That's what we're looking for evidence for. You haven't given us anything. You're talking about the moon right now, a light in the sky. So no, you don't get to just beg the question and say, oh, I see the moon appear differently here, so I'm going to assume I'm on a giant spinning ball and I've walked to the other side, so I'm now upside down to my original position. No. It's not about me explaining, dudes. It's about you, remember, saying you were going to prove that the Earth is a ball. Could you provide some evidence for that?
The Earth is a ball, and you're saying that I'm begging the question.
No. Yeah, you are. Okay, so why does the moon appear to be upside down from another position on Earth?
Because it's along the middle, and then when we see it from the top, we see the top part being emphasized. When we see it from the bottom, we see the bottom part being emphasized.
So why is the moon appearing to be upside down?
Because when we see it from the top...
The top of what?
The top part of the Earth, essentially.
Which is what shape in this imagination scenario?
Oblate spheroid.
Oh, okay, yes. So you've already got your conclusion baked into your premise. That's called begging the question. It's a logical fallacy. Yes, it is. All right, so do this without assuming that the Earth is a ball already.
It's impossible to do it, because then it would contradict...
Well, there you go. So you have to beg the question. No. See, in this example, you're assuming that the Earth is a ball. I'm asking you for evidence that it is a ball. Could you not do that? Could you know how begging the question works?
No, because this is...
Do you know how baseless claims work? Because this is what you're doing. So you just agreed. You just agreed that you were assuming the globe in your argument there. You were assuming the globe.
I came to the
Yes,
conclusion.
you were at the top of the ball, and then you were at the bottom of the ball. That was your assumption, wasn't it?
No, my first assumption was that.
You just said it. You said you were at the top of an oblate spheroid. You just
That was
said
my
it.
conclusion. That was my
No,
conclusion.
that's your assumption. That's your assumption for why you're observing it.
When you're looking at it from Ontario, it looks.
You're at one side of a ball. You're already assuming that you're on a ball. So you're not assuming. So you're not. Okay, so you're not on a ball. No, it's in your premise, dude, and your conclusion. That's the whole point.
It says my assertion does not involve a ball.
Yes, it does, because you said you see it. You see it appear to flip upside down because you've moved from one side of an oblate spheroid, is what you said, to another. That's what you said.
Yes, and that is the conclusion.
That's your premise. No. You're saying. Okay, let me put it this way. So you're saying it would be like, if the Earth is a ball, then I'll see the moon look like this from here, and it'll look like this from here. I see the moon look like this from here, and this from here. Therefore, the Earth is a ball. That's your argument.
Yeah.
Yeah, that's a begging the question fallacy.
Another part of this argument is that this premise would be.
That's a fallacy, dude. That's a fallacy. Yes, I just formulated a textbook begging the question fallacy. Dude. Don't just try and talk through me.
I have the best explanation. The reason why the Earth.
Stop, dude. Stop.
I have just one thing to say.
No.
The reason why the Earth is
We're in the middle of a conversation, dude. So you just wait. So I just formulated that argument as a begging the question fallacy, and you agreed with it. So yes, as a begging the question fallacy.
This observation is impossible if the Earth is flat. Because
let's see, Cyclone.
Cool story, dude.
Can I help him with this one real quick?
Sure, yes, please try.
Okay, so Humpty, let's take a simple way that we can prove that this does not dictate the surface that you're standing on. Get a piece of paper out and draw a big 6 on it.
Yes.
And I want you to tape that 6 to your ceiling. And I want you to go to one end of the room where you see the 6 look like a 6. Then I want you to go to the opposite side of the room and look up at it, and it's going to become a 9. In any of that scenario, did the floor start curving on you, or is your floor still flat?
It is still flat. But the thing is that...
Okay, so seeing something that is upside down from one angle to another, according to your idea of what upside down is, does not dictate the shape of the surface that you're standing on, does it?
And this paper containing the 6 cannot remain static in the sky. It has to move.
Okay, so put it on a moving ceiling. Does that change the shape of your floor?
Putting it on a moving ceiling, does that change the shape of my floor? Okay,
yep.
That's an interesting way to view it.
Yeah, so there goes the assumption that you need a ball to have this kind of observation in the first place. So we still haven't got anywhere near proving that the Earth is a ball. You've just been speculating on the moon for 20 minutes. So does anyone have any evidence that the Earth is a ball?
If I do look at it from this flat perspective, so yes, if I'm looking at it from the top and the bottom, then it would look like. Let me just think this through. 6, 9. That's fine.
Dude, just put yourself on mute and think about it. We can open up to the rest of the room.
This would flip its axis. But now the thing is that since the ceiling is a moving ceiling that we have established, now how does this move?
We don't require to evidence why it moves. It's sufficient to show that if it was moving, you could have the same observation, so it doesn't mean you live on a ball. Okay, so do you have any evidence that the Earth is a ball yet? You found any?
How does the ceiling move then? How does this move?
We don't make claims to that, friend. No one here is making a claim about that.
I would explain this multiple times. We're not making claims about it.
I'll make a claim to this.
No. We don't care. We know what your claims are, dude. We know what the claims are. What we're interested in is evidence that the Earth is a ball. You understand that? Yeah. We don't care if you can repeat the stories about the lights in the sky. We know the stories. We want evidence that the ground, not the sky, the ground is a curving, spinning ball. Could you please provide something that involves the ground?
If something is static in the sky, then...
Dude, did you just listen to what I said at all?
No, because it's irrelevant.
Okay, well then put yourself on mute. We'll speak to someone who isn't just going to be rude.
I'm not being rude.
Yes, you are. You're ignoring the conversation.
I'm not, because...
Yes, you are. You're repeatedly going to this non sequitur that you want to stay on because you know you don't have anything for the Earth being a ball. And it's annoying. You're not even being honest.
Okay.
Yeah, we've already listened, dude. We've heard all your stories.
Well, you don't know if you've heard all my stories.
Yeah, I've heard all your stories. It's the same stories that every other globe believer gives us with absolutely no evidence.
No, here's the thing.
No, you're not going to talk about the sky. We've spoken about the sky. If you want to keep talking, we'll be talking about the Earth, yeah? That's what the channel is. It's about the Earth.
Have you studied physics in your life ever, to the most basic level?
Well, what element of physics do you think proves you live on a spinning space ball?
Gravity.
Okay, what does define that term?
Oh no, open a physics textbook for the definition.
Well, no, it's your claim, isn't it? So you need to define it. So this is the thing that proves the Earth's a ball to you, but you don't know what it is.
I'll define it. Okay, G, M1, M2 by R squared. There you go, that's gravity.
That's not a definition, that's the equation.
That is a definition. That is a mathematical.
No, that's not a definition. Is that what it just says? If you look up gravity in the dictionary, that's what it says?
Yes, in the scientific theories.
Okay, show me the dictionary where it just says that formula for a definition of gravity.
Well, no, if you would have heard.
Yeah, dude, stop bullshitting. Stop bullshitting. Okay, so you are bullshitting. What's a definition? What's a definition? Do you know what a definition is of a word?
What
Do you know what a definition is? Yeah, go and look up your own
fundamental
argument.
interaction, which is what I said. One of the fundamental
No,
forces,
you didn't say a fundamental
which is what
interaction.
I said, and mutual attraction between all particles. There you go. You have.
Yeah, none of that. Yeah, none of that was what you said.
Okay, repeat what I said then, since you are so good at listening.
Yeah, you quoted a formula first, which had no words in it, and then you just told us the actual definition that you found, which obviously didn't have anything that you said before.
Something in between. I said that it's an attractive force. It's a fundamentally attractive force.
So you're talking about Newtonian gravity?
Yes.
Okay, you're aware that that's been out of date for over 100 years?
It still explains systems.
It still explains systems, even though it was superseded 100 years ago.
By what? Go ahead.
You don't know?
No, I don't.
You heard of a guy? Okay. So let's just. So gravity isn't going to be a good argument for you then, since you don't know the current concept, which is Einstein's gravity. You know Einstein?
Okay. Could you please educate me on that?
Well, he says it's not a force, for starters. He says it's the consequence of an uneven distribution of mass caused by the bending and warping of space-time.
And
do you agree with that?
Yes, I have heard this before, yes.
Do you believe it's true?
Yes, I do.
Wow, so you didn't even know what it is, but just as I said that sentence, you now believe it's true.
No, because I've heard about this before.
Oh, so because you vaguely heard about it, you believe it's true?
Yeah.
Is that how you go by accepting your beliefs? You just vaguely hear about things and you just believe it?
Again, I could start a ramble and I could ask you to define vaguely.
Yeah, you could try and non sequitur off the point, but I mean, I think it's pretty clear that's not a good foundation for your belief, just to have vaguely heard the terms and say,
so if
I believe it.
That a static object cannot stay in equilibrium in a system where there are attractive forces at play.
I don't know. Well, your argument was that gravity, this is what proves that the Earth is a spinning ball, wasn't it? So how you need to go from Einstein's bending and warping of space-time concept that he imagined to somehow making the ground outside a spinning ball. How are you going to make that leap?
Okay, so essentially, it is basically one of those analogies where you put a big marble on a mat, isn't it? And the mat bends around, and that explains gravity.
Say that again.
It's one of those analogies. This
an analogy. I thought you were saying this was reality.
You could cherry pick words, and
no. It's a very clear distinction. You're saying gravity, this word that you didn't actually know what it currently meant, proves that the Earth is a spinning ball. And now I'm asking you how you're going to get from the concept. Hold on, dude. Hold on, dude. I'm in the middle of talking. Now you need to go from the Einstein's concept of space-time bending and warping into the ground outside in reality being curved and in motion. So you tell us how you get there, and you're just saying, well, imagine we put a marble on a mat.
Yes, and then this mat represents space-time, and then it would curve space-time around it. And then things.
Right, does space-time actually exist, though?
That has nothing to do with the Earth being flat.
Right, so your argument about gravity has nothing to do with the Earth being flat or a globe, then?
So let me get this straight. First, you asked me to argue on the Einstein's gravity.
Well, no, because you said gravity, so that's what it would be in your globe belief. Well, I was correcting you. I was just making sure you're arguing the right pseudoscience.
Right. So first, to please Your Highness, I must converse with you on the Einsteinic sense of gravity. Then that involves bending of space-time. Now we come to a point that whether space-time exists.
Yes. Is that real?
I don't have information on it.
Okay. So if you well then in that case, why would it be proof that you live on a spinning space ball if you don't even know that that's real?
Because we could take attractive forces as observation.
Right, but you're claiming a space-time mat somewhere, and that's apparently the causal mechanism for you, not your attractive forces. But you say you don't know if it's real or not. So how's that getting us anywhere? We go outside, and the Earth is flat and motionless to every human being on Earth. But because of this concept that we don't know if it's real or not, we should assume it's not what it looks like. But hey, if you want to keep talking physics, we're all about it. We like physics.
The best thing about physics is that you can do physical things to prove whether or not there's a cause and effect relationship. But with space-time, it's really difficult because it turns out that space-time is not physical or material. Bummer.
Yeah, which is going to make it hard to bend and warp, since those are physical attributes. So if we metaphysically bend and warp an imaginary concept, we can believe we live on a giant spinning ball. Makes sense.
Also begs the question, because apparently the marble on the mat is already a ball.
All right. Anything else? Any more questions? Have you seen the curvature of the Earth? That's what we're asking today. Have you seen it? Was it good?
I'm trying to understanding
Understand?
properly.
Okay.
Understand properly, yeah.
Well, we can explain it very simply, if you'd like.
I am into physics and astronomy, cosmology.
Mm-hmm.
But
what about the Earth? You into the Earth?
I know that's a ball.
How do you know that it's a ball?
We can explain it by Pythagoras, you know.
But that would be assuming in calculation. How do you prove that it is a ball in reality?
How to explain it?
Because we don't experience the Earth to be a ball. Do you agree? We experience it to be flat and motionless. When you go outside?
We are flying some kilometers from the Earth by airplanes, and we see the horizon.
Yes, the horizon is horizontal, even from a plane. It's flat.
So you believe
No, we see.
The Earth is a flat for you?
We observe, we see, we measure.
How do you measure it? How do you measure it?
Turn your mic down, friend.
Yes, but answer my question also.
Oh, Kiri. But no, we're in the middle of a conversation with a new guy, Kiri, so you'll have to wait. This has been explained to you many times, though, remember?
Yeah, but I'll mute myself. But can you answer the question?
Someone posted some of the laser tests in the text channel earlier. So scroll up and watch some of the videos of the laser tests that people are doing.
So that would answer my question. How do you measure?
There you go. Go and watch those videos. Put yourself on mute. So where were we, Damien? We observe and experience and measure the Earth to be flat, the horizon to be flat. But you're saying it's curved, so we need evidence for that. What's the evidence?
First of all, we made a science to research our environment. So if we use Discord and now we talk each other, we believe the science works.
No. That's technology. That's technology.
Yeah, but technology
It doesn't relate to the Earth. No, the use of Discord does not require a globe Earth.
No, it's just correlation or something like this.
No, there's no correlation. They're different things. What we need is like a measurement of the curvature or a measurement of the ground spinning. Because you're saying it's a spinning ball, yes? So this is geometry. So could you prove that the surface is curved or spinning? You have to prove both, but let's try one at a time. So do you know anyone who's measured curvature? What about motion? Other than an earthquake or something? What do you think?
I don't know how to explain it in English.
You can take your time, you can read through it and then figure out how to say it, or you can ask us to help. You even just need to get a name or a method Doesn't have to be a long explanation. Can just be this guy on this date performed this measurement using these tools. Simple, yeah? Or you could send the link to what it is you're reading.
I've asked my question in the chat. If you want to answer, that would be nice. Thank you very much.
What did you say? But how do you measure it, though? Lasers and satellites, right? Well, I don't think anyone mentioned satellites. Did you watch the laser video?
I watched it, but still, again,
okay, what did you observe?
For the fifth time, how do you measure?
What was the video about?
How do you measure distance?
So what is the video? What did they do in the video?
Okay, so I'm asking for tools of measurements. What are the tools of measurement?
What do they use? What do they use?
And you're referring to. Hear me out. You're referring to a video. There's no
what did they do in the video?
I'm asking a question. Simple question.
You said
how do you measure? How do you measure this?
Kiri, you said you watched the video. Why are you spiraling? So what did they do in the video?
They're using like common tools where we can actually see.
What tools?
No, you tell me.
You said you watched it.
No, I'm not answering that question.
You're just lying. Yeah. See, I don't know why you're so upset, Kiri. Is this because you got flat smacked around like 3 days straight, and now this is what you're doing? Well, watch the video, and when you can discuss it, we can talk.
Damn! What a scumbag! Flat out lie. Like, blatant. Holy shit.
That's what they do sometimes. And you know, Kiri, even that alone should be making you think, like, why do I, if I'm on the position of truth with the globe, why is it that I have to resort to blatant, childish lying when I'm discussing the topic? Seems like a contradiction. How you getting on, Damien? Found anything?
I find Aristophanes.
Aristophanes.
Yeah.
Yes. What did he do?
He proved it by.
What did he prove?
He proved just the. Wait. One word. Circuit. So no, it's the wrong way, I think.
What have you just read? What are you thinking? He didn't prove that the Earth's a ball?
I think not.
Correct.
But,
good for you, Damien. You're quick. Is that Hyrixa? Hyxera, however you say that. Welcome. Ilyes, what's up?
Hey, what are you discussing here?
Keep going. We're asking if anyone has any verifiable evidence that the Earth is a spinning ball, like the ground beneath our feet.
Yes, I have a piece of evidence actually.
Okay.
You can go on YouTube, and I'll find you a video. Hold on.
Great. Now, will we be able to verify that this video is real? Because you understand, it's not very difficult to make fake videos nowadays.
No, of course. You will look at it and you'll just immediately know that it's real.
Oh, right. So you're just accepting it on face value?
Come on, man. You will see what I'm talking about here.
All right. Well, then you can walk us through your verification method. I think you just did, right? You just watch it and then you go, cool, and believe it, right?
Place on Earth where sun never sets. That's the proof, basically, that the Earth.
The sun never sets?
Yeah.
I thought it was a video of the Earth being a ball. I thought you said it was of Earth being a ball.
No, I didn't say that. I said that's the.
Oh, but that's what we were looking. That's what we asked for the proof of, that the Earth is a ball. Remember?
That's the proof of that the Earth is a ball. Because if it wasn't a ball, the sun would eventually set somewhere.
Oh, so this video affirms the consequence.
Yeah.
Yeah. Could you make that a logical argument? Could you phrase that into a logical argument for the globe?
Yeah.
Okay. Let's hear it.
Put that into a logical syllogism.
How about this? Maybe I'll help you out. You don't have to use mine, but if the Earth is a ball, the sun will never set in this location. The sun never sets in this location, therefore the Earth is a ball. Is that kind of what you were going for?
Yeah, I thought that was not enough.
No, that's called affirming the consequent. It's logically unsound. It doesn't even make sense.
It makes perfect
sense. It's circular reasoning. No, it's circular reasoning. See, because the Earth actually needs to be proven to be a ball. Otherwise, you're begging the question of the ball and saying that this is one of the consequences of the Earth being a ball, and that's why it is a ball. It's actually just affirming the consequent. It's a formological fallacy.
No, it makes perfect sense. Just give me a second.
Well, to you it does, because I think you've been trained for the most of your life to just affirm the consequent with these types of things.
Yeah, it's a famous training. They trained that in school, right?
Right, so you've been trained to have bad logic, and now you're applying that bad logic with this particular observation.
That's a textbook logical fallacy, bro, not an argument. So, because what you're really just observing is the sun moving in the sky above a flat, motionless Earth, and then you're imagining it's a ball. But we need some measurements, some evidence that it is actually a ball. Don't just assume it. So have you got any of that? Got any measurements of the ground being a spinning ball?
Just give me a second. Just give me a second here.
He's checking the filing cabinet. Is it in here? Is this where the globe proof is? Why didn't they teach me this at school? Why am I only finding this out now? As I'm mid-argument. All right, well, while you're getting it together, do we have anyone else who wants to offer some globe evidence? What's up?
Oh my God. Okay, listen. I got an explanation for you. Listen. So, it's gonna be long. So tell me, are you ready to listen for me for?
No, be concise, dude. Well, be concise, dude. If it requires a minute or two of just like rambling, that means it's not evidence. Be really succinct. But try. Go ahead.
I'm ready to give you an evidence here.
Okay. Let's hear it. Let's hear it.
So this is not something that came out of my mind, yeah, but it's logic that you wanted. Here's the logic. Listen, the phenomenon of sun never setting in certain places on Earth, such as the Arctic Circle during the polar day, provides evidence that the Earth is a globe. Here's the explanation. The sun never sets in regions like the Arctic Circle during summer months due to the Earth's actual tilt of approximately 23 degrees. This tilt causes the North Pole to be continuously oriented toward the sun for about 6 months, resulting in 24-hour daylight in areas within the Arctic Circle. This is known as the midnight sun.
Okay, can I just jump in at this bit?
Yeah, go ahead.
So now you'll need to provide not only evidence that the ground is a ball, but also that it's tilted. So who's measured the ground to be tilted?
Tilted, yes, tilted.
Hey, you don't ask these kind of questions to everything, do you? Why you
yeah.
this?
If you make a claim, such as the Earth is tilted, then you'll be asked to provide evidence. Dude, stop doing that. Put yourself on mute. So if you make a claim, hold on. I'm just clarifying. This is how it works here.
Yes.
If you make a claim, such as the Earth is tilted or a ball, then you will have to provide evidence for that claim. That's how it works. So now you just added another claim that the Earth is tilted. So we need some evidence for that now.
Listen, man, listen.
No, dude, don't interrupt. We'll get to you in a minute.
I don't have anything to say.
Okay, fine. All right, new dude, you're up. What's your evidence? Yeah, what's your evidence?
It's not evidence. I want to know your opinion on it. Well, during a lunar eclipse, if you know what I'm talking about, solar eclipse, lunar eclipse, you can see the shadow of the Earth on the moon's surface, and you could see it as a curvature that would fit the sphere. If the Earth was flat and it somehow had its shadow on the moon, it would have been straight, wouldn't it be?
Okay, two questions. One, how do you know that the darkening, the eclipse that we observe, is the Earth's shadow on the moon? How do you know that's the case? And two, have you ever heard of the Selenelian eclipse?
The what in the eclipse?
It's called the Selenelian eclipse. Someone can post it in the chat, but it's basically someone will send it and you can look into it. It debunks the eclipse being the Earth's shadow. Geometrically doesn't work because they have to be in a straight line for Earth to be casting a shadow onto the moon. They have to be in what they call syzygy. But in the Selenelian eclipse, both the moon and the sun are observed above the observer's horizon at the same time, and the eclipse occurs on the moon from the top down. So geometrically, you can't have the Earth's shadow coming up between them when both the sun and the moon are visible above at the same time. So whatever it is being caused, it's not the Earth's shadow, a ball Earth shadow. The eclipse just occurs. The moon is its own light source, if you ask me. And it has its own phases. It does its own thing, and the eclipses occur as they do. I don't know what the actual mechanism is. You can speculate. We can't prove it. But we can be fairly confident that it's not the shadow of the Earth, because the Selenelian eclipse debunks that geometry.
Oh, okay. So, all right. The argument here is that there's no way to prove that it's the Earth shadow. But
well, that's one point. That's one point. Yeah, but we can also directly disprove the globe claim with the Selenalian.
So, did someone send it in the chat yet? Oh, I can see it. Okay. Okay.
But yeah, we're not generally making claims about what the sun, moon, and stars are doing. But whatever they're doing it above a flat, motionless Earth.
Oh, I see. All right. But so the claim is, let's call it the claim. The claim is that, like, if the Earth was round, we shouldn't be able to see both at once, right? Like the sun and moon. The sun and moon.
Well, they have to be in alignment for that to occur. They have to be in a straight line with each other.
All right.
Sun,
So both can be seen up the horizon. So that's kind of proves that Earth is flat. Is that basically the claim?
No. No, not saying that. It doesn't prove one thing or another. It just proves that that story that you got told isn't true.
Isn't true.
Yeah. About it being the Earth's shadow.
Okay. All right.
Yeah, that whole solar system, space concept that we're shown on TV and in textbooks, that doesn't exist.
Doesn't exist.
Doesn't exist.
But would you say you have enough expertise to make that claim? Like, as if you haven't, have you studied that?
You don't need an advanced degree. You just need to understand gas pressure and how it works. Do you know what gas pressure is?
Yes, I'm an oil and gas engineer. I know what gas pressure is.
Right, okay, perfect. So gas pressure is the force exerted by the gas on the walls of its container. As an oil and gas engineer, you'll know full well pressure-containing vessels require a vessel, yeah? And then the gas will press off of that. So if I were to ask you to give me gas pressure without a vessel, could you do that?
Well, let me just translate with a vessel. Sorry.
I didn't hear what you said there.
Oh, let me vessel. I just need to translate. Sorry.
Container.
Okay, a gas without a container.
Yeah, so gas pressure is the force exerted by the gas on the walls of its container. So when it presses against the pipe, the tubing, the container, right? And so for it to be pressure, it needs to be pressing against a physical container.
Yeah, that's the easiest way to explain it. It's associated with a container.
And you wouldn't be able to. Hold on. Let me just get to a conclusion.
Yeah, wait. Let me just explain. Let me just tell you one thing that I'm not trying to argue here. Get me? I'm not trying to say one's right, one's wrong. Just trying to know your opinion on it. There's no negativity in what I'm saying.
No, that's fine. That's fine. No, I get that. I appreciate it. You're being chill. It's good to meet you. But I'm just because you're an oil and gas engineer, you will understand this perfectly. You can't have gas pressure without the container. If the container's not there, the gas will just expand into the available space. High pressure flows to low pressure. Entropy. Yeah?
All right. Yeah.
Okay, so the air that we breathe here on Earth is a pressurized gas at around 14 psi at sea level. Yeah?
Yeah, go on.
So in order for that to be a pressurized gas that we're breathing, it must be pressing against a container.
Okay. All right.
Meaning we're not in this vacuum of space in an open system adjacent to the vacuum. We're in a contained system, a closed system.
Okay.
Yeah, like a terrarium. Don't know if you've ever heard of a terrarium.
Terrarium, yeah.
Yeah, look into those. That's a sealed container. You put in the earth, the dirt, you put in some water, and it generates its own water and gas cycle, just like we have here on Earth in a contained system. So the whole space story that we've got isn't true. It's a violation of natural law. They're saying this high pressure on Earth isn't flowing into the low pressure of space, when we know high pressure flows to low pressure. And the only way you can stop it is to contain it.
All right, yeah. Well, can I speak now? Is it okay?
Yeah.
I'll tell you my idea of it. I mean, that's what we've been taught. You know, oil and gas pressure is disgustingly important in transportation during the pipeline. But the idea of gas pressure and its association with the vessel, a container, right? we use a container as in it's a very easy way to explain what a gas pressure is, but
it's the only way to achieve gas pressure.
But the gas pressure is pretty much the result of gas molecules, basically gas, colliding with the surface, right? And we use a
container surface.
Yeah.
Yes.
A container is a surface, but gas can also exist like without a physical vessel. As you said, yes, air pressure.
Gas could exist, but the pressure couldn't, because it would have to press. It needs to
gas
press.
Pressure, air pressure.
Yeah, so that wouldn't. So that would require a surface, like you've just described.
The thing is, as you said, 14.7 psi or 100 kilopascal is the air pressure at sea level, and this pressure exists. Molecules collide, creating pressure.
They press against the container. They can press against the
gravity, I mean, I'm telling you, the container here is the gravity, basically.
Because, no. Gravity is not a container.
Yeah, let me just finish my part real quick. There are examples of planets without gravity, right? Or with low gravity. I don't know, Mars, I guess. So in Mars, particularly,
dude,
air
because this is where you go into
space. And in our idea, the solid container is the gravity. Gravity pulls air molecules downward.
No, that's not occurring. Air is moving omnidirectionally in all directions on the surface, including up. It's not being pulled down. So, and gravity is not a container. You can look up the definition for the word container.
Gravity is not a container. No, it's not a physical container. But
it's not. It's a concept.
Gravity pulls air molecules downward.
No, gravity is not a force, dude.
Creating pressure.
No, that's not occurring.
That's how we have air pressure without a solid container.
No, dude. Think about the application in reality that you're very familiar with as an oil and gas engineer.
Mm-hmm.
We deal with that. That's what we deal with. Reality. What occurs in reality. Not what they've told us and we can never demonstrate and contradicts everything that we do experience in reality. Because in reality, high pressure flows to low pressure, and there's nothing you can do to stop that but contain it. You're telling us, no, you can do something else, but you can't demonstrate it. So that's just a belief. So the point is, we're in a contained system. That's how we know space isn't real.
Space isn't real, okay.
Yeah, we're in a contained system.
Okay, I'll quickly finish what I was trying to say. So that's what I'm trying to say. Again, that is what we've been taught. That's what we work with.
So we've been told, but it's not what you work with. What you work with is containers, practical reality. You might have been told something else, but you, as an educated man, should then go and say, all right, what is my proof for this claim? What experiment, what data have I been shown? What can I obtain? You need to go and find that evidence, because at the moment, it's just a claim.
All right, well, then I'll finish my claim then. I need to paraphrase it. So, I'll go chronologically. Gravity pulls air molecules downwards, like down to the Earth.
Is that observed?
Without gravity, which acts as a container, without gravity air molecules would escape into space, right?
Right. Well, is you just said air is being pulled down to the floor? What's your evidence for that? Because as far as we can tell, air moves in all directions.
Mm-hmm. No, I mean, as in the planets that do not have gravity.
But this is where you're just relying on the stories you've been told about these lights in the sky. You don't actually know any
gravity is not a force? Did someone say that?
Yes, the mainstream globe proponents say that it's not a force.
Okay. It's a fundamental
They say they say it's a consequence of the uneven distribution of mass caused by the bending and warping of space-time. That's what they say.
Okay.
That's Einstein. And that's just a fantasy concept. So no, this fantasy concept is not holding the air next to a vacuum and stopping it from equalizing. Only a physical container can do that.
All right.
It was nice talking to you, though. Go and think about it.
Stay blessed, man.
Okay.
Yeah, thanks for stopping by. Come back anytime.